AP Statistics, welcome to 1.3. We're going to talk about we're going to describe quantitative data with some numbers. So we're going to be able to describe location. We're going to get some better measures of center and spread now, because remember, when we're describing a distribution, we need to not forget our SOCs, right? We need to describe the shape. We need to identify any possible outliers or extreme values. We're going to be able to actually calculate to figure out definitely if a value is an outlier or not. Then we also need to describe the center and the spread or variability. We're going to finally have some math that we can use to describe a distribution, right? Center, spread, outliers, and those types of things. So let's get right into it. Yeah, that's what I said. Okay. I'm sorry that this slide really sucks. So what we're going to do, it's finding the mean, so it doesn't matter. You know how to find the mean. It's an average, right? You add up every value in your data set and divide by the number of values. That's what this thing says. So another thing we need to talk about is this guy right here. I call this X bar. Actually, everybody calls it that. Okay? That's X bar. That is going to represent the mean of a data set. Okay? So it's the mean of a sample. And then that equation is just pretty simple. It's the sum of all your values divided by the number of values. Yeah, the Greek letter sigma, by the way, this thing is called sigma. But this is uppercase. Sigma is also this, and this is lowercase in Greek. Okay. We're going to use both. This sigma refers to a sum. This sigma, we'll find out very shortly, represents our standard deviation. The median. You can read that. No, you can't. It is the center of your observations, okay? So let's just write that down. Is there a way to fix that? I don't know why that keeps happening. The median is literally the middle observation. You literally count in. All right, so we're going to calculate the mean of these. Right, we're just going to add them all up, divide by the total number of observations. The median is the exact middle. So why am I adding this 20 plus 25 and dividing by 2? Well, let's look at it. We have 20 observations here, it appears, right? I'm gathering that from this denominator here, forgetting I'm recording a video and you can't see where I point. Okay. But let's count in, right? So we're going to go, right, it's the middle of this thing is going to be 10 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the middle is there, right? The middle is actually right there, yeah? Oh, shoot, these are not ordered in sequence, so no. They have to be, so before we can calculate a median, we have to put these guys into sequence from least to greatest, and then we would count in to find the median. I'm going to do that here in a little bit with a better data set. We'll order it, but just to get the idea, if you have 2 in the middle, right, if there's not a middle one, so for instance, with an even number data set, right, there's not going to be a middle value, right? You'll have the same amount on each side. With an odd data set, the median will actually be that one value in the middle. So there are two different ways to calculate medians. Again, your handy dandy calculator will do that for you. Ooh, here we go. New stuff. Hopefully, maybe you've never seen, well, maybe you've seen interquartile range before. Maybe you have not. For a lot of people, this is a new concept. The interquartile range is a very, very good measure of spread or variability for data sets that are skewed. So if your data set is not roughly symmetric, skewed left or skewed right, the measure of center that you would use for that particular data set is going to be interquartile range. The way that you calculate interquartile range is you find basically the median on the left-hand side of your data set, if it's arranged in sequence, and then the median on the right-hand side. Those middles are your quartiles. Your quartiles split your data into quarters, right? So 25% of your data is below quartile 1, while 75% of the data is below quartile 3. And we'll get a much better description of this. And I'm actually going to add a little something to this. That I would use interquartile range for measuring variability or spread of skewed data, skewed distributions. Let's say that better. I think that's an important fact. Yeah, we're going to do this later. All right, the 1.5 times IQR rule for outliers says that, wow, I hate this. Okay. I'll just write it for you. If a data point is below Q1 minus 1.5 times your IQR, or above quartile 3 plus 1.5 times your interquartile range, it is an outlier. So now we can specifically say whether we definitely, right? We're not just going to look at it and say, hey, that looks extreme. We're going to make a calculation and say 100% that's an outlier. And cool news is your calculator does the exact same thing. And when you plot a data, when you make a box plot, it will identify an extreme value as an outlier for you. You'll be able to pick that out. That said, though, you're definitely going to have to show these two calculations at some point in time. Not just once, lots. Okay, very important. Yeah. All right, our 5-number summary. Again, this looks really bad, but I'll write it down for you. Your 5-number summary is going to look like this. Whoa, that's a weird. I just got a little carried away. Our 5-number summary, it's going to go like this. Minimum. Quartile 1. Median. Quartile 3. Max. That's it. Those are your values. Okay, so if you're given a 5-number summary and you have a number, a number, a number, a number, a number in that order, it's assumed that you know the first one is the minimum, the second one is quartile 1, the third one is your median, fourth quartile 3, fifth one is your maximum. So you'll be given a 5-number summary with just 5 numbers. It's assumed that you know which one is which. Okay. 5-number summary is absolutely essential for creating a box plot. That's where we're moving right now. How to make a box plot. I'm gonna do this. Don't worry about it. In the next lesson, the next video, if you will. I'm gonna go ahead and just do one of these for you rather than showing you this. So we're going to talk about a standard deviation. This is a really terrible picture of it. We're going to move on with that. Hey, guess what? You're never doing this, okay? All right. Calculating the standard deviation by hand. We're going to get a feel for it, what's going on, how it's calculated. I think that calculating it by hand is an extreme waste of time. No statistician would ever do it. We have calculators for a reason. These calculations are really, really, really nasty because that's what it is. So this is how you calculate your standard deviation. Your standard deviation is the square root of your variance. Now what is this? So our variance is each x value minus the mean, square it. Add the next x value, subtract the mean, square it. You can imagine that if you had a data set that had 10 items in it, 10 data points, you're going to be calculating for a long time by hand. And there's a very good chance you're going to make a mistake. Just copying and whatever, going from your calculator, all the squaring, all of that. So this is the formula that I like to go with. This is the formula you're going to see. This formula is on your formula sheet that you get to use on your AP exam as well. Okay? The formula sheet for the AP exam for this is real good. Yes. Yes. Anytime you take a test in this class, you will have everything that you have available on the AP exam. So that's calculator, formula sheet, and then there are a lot of tables that we're going to use in this class. So you'll get all of those tables, you'll get your formula sheet, and you'll be able to have your calculator on the AP exam. So this is what I was alluding to right here, okay? You have to choose the correct measure of center and spread. So if your data is roughly symmetric, we will use mean and standard deviation for measures of center and spread respectively. If we see data that is skewed or has extreme values, has identified outliers, then we are going to use median and interquartile range for measures of center and spread respectively. So the reason why we do this, imagine, right? If you have some data that is roughly symmetric, just imagine that we've drawn a curve to that data, right? If it's roughly symmetric, then, you know, your mean is here, right? And probably if it's symmetric, right, this is also going to be your median, right? In fact, if it's perfectly symmetric, your mean and your median will be exactly the same. Now, what's going to happen is if I have some data that's skewed, let's put let's draw a curve that would be considered skewed to the right. This peak is actually going to be a better representation of our median. And what's going to happen is our mean is getting pushed to the tail. And that makes sense, right? Think about the way that we calculate an average, right? If I'm calculating an average and I have, like, say, a very large high value, right? That's going to increase my average, right? So we don't want that, right? We want a better measure of center. And that in that case would be median, because our mean is getting pushed towards the tail. It's no longer very accurate. Yeah, no, just remember your socks. Don't do this. Yeah, we did it. All right, everybody. Now let's get down to it. Let's make some stuff, right? Let's determine if some stuff's outliers. Let's make a box plot. Let's look at interquartile range. Let's get some specific examples. So thanks for watching this little intro with some definitions. I hope you're having a great day, and if you're not, I hope it gets better. Thanks.